Jay, if we have others that come on a little bit later, if you could go ahead and allow them access into the room, that'd be great.
Yep, I'm on it.
All right, so welcome to Tech Tuesday. Today we're going to be discussing the Herculine electric actuators. These are the higher torque actuators. These are the Herculine 2000 series and the 10260. Most of the time these are used in industrial applications, on dampers, on butterfly valves, gas valves, air valves, things of that nature. Let's go ahead and dive into the Herculine actuators here, and we'll have a little bit of time at the end where we can answer some questions that you guys might have. So let's go ahead and begin. So the industrial actuators, typically these are used on modulating systems, on valves and dampers. They are the final control element in the control loop. So as you all know, in a control loop, you have your sensor, your PID controller, and your final control element, which is your actuator. And the actuator, or the final control element, plays a very key role in the PID loop. This is what gives you the accuracy of your control, allows for reduced dead time hysteresis, and allows sometimes for cost savings based on how good or poor the control is. So those are just a couple examples where they're used in valves and dampers. The Herculine actuators are used for precise control, repeatable positioning of industrial dampers and valves. It has exceptional reliability, low maintenance. These actuators, in some cases, have been out in the field for 20, 30 years. In the case of the 10260, we have these actuators in a lot of very harsh environments. These would be including in steel mills, sometimes in concrete manufacturing, limestone operations. There's been several times where I've walked out into plants and the whole actuator is encased in limestone, and you can't even see the actuator, but it's still moving, still doing its thing. So these do operate in some very harsh environments. These do have electric rotating actuation. So in some cases, we're supplying a 4 to 20 milliamp control signal to this actuator. Sometimes it's 0 to 5, 1 to 5, 0 to 10 volts from the control loop. In other cases, we're providing just a simple on-off discrete input to the actuator that allows it to increase or decrease the rotation on the valve depending on where the process needs to control at. These also offer a slide wire feedback control. In the old days, it was called PAT, or position adjusting type, and that would be considered a slide wire feedback control that utilizes a non-contact feedback signal into the control loop from the actuator, and then from the control loop, an increase and decrease digital output to the actuator to position it. We'll get into the electronics a little bit later in the slides, but just to know that you can do either 4 to 20 on-off or position proportional control with either one of these actuators. On the right-hand side of this slide, I have the 10260 at the top and a Herculine 2000 series at the bottom. Just to give you a little bit of background on where both of these drives came from. The 10260 actuator was a purchase that Honeywell made probably about 20 to 25 years ago, I believe, a company called Leeds & Northrop. Leeds & Northrop had the 10260 for years and years, workhorse out in the industrial plants, and with the purchase of Leeds & Northrop, Honeywell brought over the 10260 and has made enhancements to that actuator over the years, adding a smart display at the top of the actuator, along with communications and some other enhancements. The 10260 is a workhorse. You can go all the way up to 300 foot-pounds of torque. So this would be required to move large dampers, other applications that require high torque applications. It does also have a 90-degree output shaft travel on the shaft or the output shaft of that actuator, it has a scale that'll show you what degree of rotation that shaft is at, but it does have the 90-degree output rotation on that shaft. On the 2000 series, this actuator came about with the obsolescence of the old Actuator motors. These would be the M740s, the M940s, and the M640s. The new Herculine actuator carries the same footprint as the old Actuator motors and the same mounting as well. The enhancements to the Herculine actuator over the old Actuator motor, the Herculine has also an optional display for configuration, troubleshooting, and calibration. It also has a hand wheel. If for some reason the electronics was to die on the actuator or power was to fail to the actuator, there's a little hand wheel at the top that allows very easy positioning by rotating that hand wheel if you needed to get in there and position it while the actuator had no power. The also has on both of these actuators, it has a auto manual switch that allows you to take control of the positioning of the actuator right at the actuator itself. So it has an auto manual switch on the side of the actuator that allows you to position the actuator. The nice thing with that auto manual switch is that if you're on a new startup or installation and you need to stroke the valve out at the valve to position the linkage that you're setting up on it, it's very easy to use that auto manual switch to ramp the actuator up, set the linkage at the high end, ramp it all the way down with the manual switch to set your linkage at the low end, and instead of going back and forth to the controller or the control loop to put the control loop in manual, you could do it right at the actuator. Saves a lot of time doing startups. The Series 2000 can go up to 400 inch-pounds. So it starts at 50 all the way up to 400 inch-pounds. And the output shaft travel can be adjusted from 90 degrees, 150 degrees, and there is also a special model, which is a 360-degree model. That particular actuator is used on a surface combustion integral quench furnace. If you get into some heat treat facilities that have surface combustion IQ furnaces, they had standardized on that 360 model a number of years ago, and you'll probably see these mounted up on the stack of the integral quench furnace. So there are other applications that use a 360 degree, but it's most widely used on the heat treat operations. Here's a couple examples of actuators out in the field and how they're mounted onto, I believe the top one is possibly a port valve, but in all intents purposes, butterfly valve with a little bit better accuracy. And you can see the 10260 is mounted on the top, and then it has a linkage assembly that connects the crank arm down to the butterfly valve. There are the manufacturers out there for these butterfly valves, like North American, Maxon, several others, actually have adapter brackets for both the Herculine 2000 and the 10260. So if you get into applications where you have one of these butterfly valves, you could usually ask the manufacturer and they'll supply an adapter kit or a mounting plate to mount the actuator on top of the valve. On the bottom right-hand side, that's a picture of a Herculine 2000 actuator. You can see it's a little bit smaller butterfly valve there, possibly a port valve, but again, connected with the linkage arm there and a rod connecting it to the butterfly valve. Probably in that top picture there is probably an example of a startup where the technician's probably using that auto manual switch or hand wheel right at the actuator in order to set up that linkage. Here's another application. This is a Herculine 10260. This is the A model. Again, connected up to some very large dampers. There's a damper on the top and then also a damper off the side. These are applications that require a little bit higher torque usually. You'll typically see these in large plants, glass manufacturing, steel manufacturing. Those are pretty typical. Also, Leeds and Northrop back in the days was really big in the power utility, and you'll actually see a lot of 10260 actuators throughout the power industry as well. Again, a couple more examples. Here's a nice example of a Herculine 2000 with a direct mounted shaft. So not only can these actuators be mounted with a linkage arm, with a crank arm, but also has an adapter bracket that allows direct coupled actuation to a damper or valve. And that's a pretty good example of it up there on the very top on how you can mount it to a damper. As we discussed, the 10260, or actually the whole Herculine actuator family, has very precise positioning to provide best efficiency for your process control. The 10260 actuator, if you're using it in a linear fashion with a 4 to 20 milliamp, it has about 1,000 repositions. So when I say 1,000 repositions, that means if you were to take a 4 to 20 milliamp signal and which 16 milliamps, and divide that up between the 1,000 repositions, that'll show you how precise of a control or a finite control. Say, for example, your controller's changing from 4 milliamps to 4.002. You're going to see that actuator move, because at 1,000 repositions, you get a much more finite control out of your 4 to 20 milliamp signal. The same thing with the Herculine 2000. That offers upwards about 500 repositions. So both of these actuators are going to take a very, very small bump in control signal to have a movement in that actuator. That's going to give you a very, very good process control. It's going to save, hopefully, energy cost, maintenance cost, and provide a little bit better quality control on the product that they're manufacturing. We discussed some of the markets served. Again, power gen, utilities, pharmaceutical, food and beverage, chemical. These are used on a lot of large utility boilers inside of these facilities, on the ID fan dampers, also the gas valves. In the thermal processing market, you'll see these a lot in glass, metal, heat treat, cement manufacturers, lime kilns, really harsh environments where the actuators need to have a good hard casing on the outside of it. A lot of times NEMA 4X, IP66 rated. So these things withstand a lot of harsh environments and very ruggedized. Other applications with inside these facilities that I mentioned on the previous slide: secondary air dampers, rotary valves, boiler feed water, combustion skids. Combustion skids supplied to heat treat, steel, glass. In the glass industry, these 10260s are used pretty widely among a lot of the leading glass manufacturers in the U.S. So typically, if you walk into a glass plant, you'll see these on the combustion skids. Furnace pressure dampers. So this is your draft pressure control that needs very, very finite control to the either the furnace or the heat treat oven, where you're controlling a draft pressure that might be down into the 0.4 to 1 inch of water column. And with that low or with that narrow of a band of doing control, you need a little bit more accurate actuator to do that control. And with the repositions that you get in the 10260 and the Herculine, it does really well in those applications. Bag house dampers, gas trains, fuel air ratio control, wind box dampers, burner tilts. Burner tilts are big in the large power utility plants that require very high torque in order to do the burner tilt. These would be typically on tangent fired boilers, where they're tilting the burners to get better firing out of the burner box. Boiler feed pumps, stoker speed control, blast furnaces. So you can see these environments are typically pretty harsh industrial type environments and require something a little bit better than commercial style actuators such as like a mod motor or some of the lower torque actuators. So let's talk a little bit more about the 10260. We'll take a little bit deeper dive into this product. Again, 10 to 300 foot-pounds of torque, continuous 100% duty cycle. So this is very, very important when you're into ambient temperatures that are in excess of 100 degrees and upwards. A lot of the actuators that are not rated for industrial climates have braking mechanisms in it. Those braking mechanisms will deteriorate over time with excess ambient temperatures. So those become less of 100% duty cycle and probably somewhere around 50% duty cycle after a period of time. The 10260 actuators, however, are rated at 100% duty cycle, and even as ambient temperatures rise in the plant around the actuator maintains that continuous 100% duty cycle because it does not have a braking mechanism inside the actuator. It's actually a self-locking worm gear that's in that actuator that's mounted right to the output shaft, which gives you high repeatability and self-locking under very high excess torque as well. The actuator also has a non-contact sensor for shaft positioning. If the customer needs to have a true indication feedback to the control system, whether it be a PLC or a single loop controller that shows the actual position of that actuator, the actuator has a non-contact sensor, which is much more accurate and less maintenance headaches out in the field. If you would have had this actuator out in the plant 10, 15, maybe even 20 years ago, they would have had a slide wire that fed that position back to the control system. And on the old slide wires, those would become dirty. You'd have to clean them every once in a while. A lot of times the slide wire arm would break, and then it would cause very erratic control or even feedback signal to the control system. So on the new actuators with the non-contact sensing, it eliminates all those headaches, and you don't have to worry about the maintenance to go in there and replace those contact positioners. The actuator has very low current draw. It has an asynchronous motor that is driving this actuator, and we're going to probably, at the end here, I have a 10260 on the bench here. We're going to open up, and I'm going to show you a little bit about the internal workings of the actuator. But the actuator, the motor on the actuator is actually protected from excess torque by a fiber mesh gear that is a breakaway gear. In the event that you have 2 times the rated torque on the actuator, that fiber gear will break before it damages the other more expensive components on the actuator. And that fiber gear is literally like 15 to 20 bucks. So I'd much rather replace that than a $500 to $1,000 motor on the actuator. The temperature ratings on this actuator is negative 20 degrees F to 185 degrees F. There's 2 models available. There is a 10260A, which is a basic model. The basic model comes with an optional hand wheel, auto manual switch, and then you can also have it in configurations of linear, which is 4 to 20 input, position proportional, or just on-off control. The model above it on the slide here is a 10260S, and that's a smart 10260. So what we do there is still has all the same features as an A, but it also has the availability to put a display on the top of the actuator where you can actually configure the stroke, you can configure the end low and high stopping positions, you can calibrate the actuator, and you can also see diagnostics and true position indication feedback on the display itself. The nice thing about these displays and the configuration, it has the same keystrokes and display keypad as most of your Honeywell UDC controllers out in the plant. So if you know how to program a UDC and move through its menu, the menu on the Herculine 10260 is the same menu structure. We discussed a little bit about the inputs. Again, you can have up and down, which is just a relay input into the actuator to drive it up or down, 4 to 20 milliamp. Also, you can control these with a digital RS-45 communication link. This is a Modbus communications, and it is a two-way communication. So you can gather information from the actuator back at the PLC, SCADA system or recording device. And it also, you can control the actuator through this communication link as well. It is a Modbus RS-45 communications, so basically a three-wire connection to the actuator to allow that communication to happen. Sensitivity adjustment is 0.2% of 90-degree span, which is a very tight tolerance, and the repeatability is 0.2% as well. Comes in NEMA 4. That is an option on the actuator, and as we were talking about earlier, you can also have the electronic hand switch, which is the auto manual switch option as well. The enhanced version offers faster setup and commissioning of the actuator, so you can basically stock one model on the shelf as a spare and pre-program it so that in the event that there is a failure out in the plant, you can take it off the shelf, go out, set up the linkage, put it in process, and you can be up and running in a very quick manner. The programming functions of the smart enhanced electronics, again, you can do calibrations, so you can calibrate the actuator 0 to 100%. You can set the fail-safe input, so in the event that you lose your 4 to 20 milliamp signal, you can set the actuator to go. You can do a characterization. So let's say, for example, you had a fuel-air ratio system and you wanted to do the curve of the fuel or air in the actuator. You could set up a linear characterization curve and then have the 4 to 20 milliamp hooked up to the actuator, and then based on that curve, the actuator would follow whatever you're putting into the actuator there. Input filtering, so if you have a noisy input, say you have a 4 to 20 milliamp input signal and there's some noise induced on that line going into the actuator, you can set up input filtering to filter out all that noise and allowing you to do very good control then. Direct or reverse acting, you can set up. Restore calibration, so in an event that you lose calibration, you can restore it back to the factory calibration, and allows a very easy keystroke in order to do that. The other features that the smart electronics allows is a lot of diagnostic information. So say, for example, the actuator had been stalled out in the field, but you really, walking up to the actuator without the smart electronics, you really don't know how long it was stalled. There is an accumulated stall time diagnostic, which allows enhanced information to allow you to troubleshoot the PID loop. High and low temperature, so it monitors the highest temperature the actuator has seen out in the field. So if you get into some conditions in the middle of the summertime, and this is right next to a blast furnace, and they're injecting 300-degree ambient temperatures and wondering why the actuator is failing, well, this will help store that for you. Total travel time, so it has an accumulator that pretty much tallies up the total travel time of the actuator throughout the work week, the month, or the year. It also shows you a number of motor starts in a period of time, the current actuator temperature, the high and low actuator temperature that we talked about, and then relay cycle counts. So if you have a high and low switch that is hooked up to the actuator, this can actually count the cycles of how many times it went to high fire and low fire. We talked a little bit about the digital contacts. I probably won't dive into this slide other than just saying that the contact sensing or the non-contact sensor that provides feedback to the control system. It has very high repeatability, consistent positioning, and it is night and day when you compare it to a slide wire feedback that some of the older style position proportioning systems have. So it'll give the system very high accuracy on where the true position is of that actuator. Now let's talk a little bit about the Herculine 2000 series. So there are 4 models available in the Herculine 2000 series. The basic 2000 series has up to 400 inch-pounds of torque, up to 150 degrees adjustable stroke. And based on the selection that you choose for your torque, it also has 6 to 75 second stroke speed at 150 degrees. So as the torque increases on the actuator, the timing slows down. So at 400 inch-pounds at 150 degrees, you'll be at 75 seconds. There are other models where you can get into the standard 30, 60-second timing as well, but that's based on the torque of the that you select in the actuator. It has a 1K ohm film potentiometer for shaft positioning. Now this is a contact potentiometer. This is not a non-contact, so you will get a 0 to 1,000 ohm feedback. You can either put a small voltage across that feedback to give you a linear voltage feedback, or you can just use the 1,000 ohms to bring back into a position proportional controller. It is a thin film pot though, so it's not a wire wound resistance. So it offers a little bit better repeatability and also a little bit less maintenance headaches. The 2000 series only comes with on-off control. You can't do a linear 4 to 20 milliamp input. And then it has 2 end travel switches and optional electronics for the hand switch and a manual hand wheel. So the 2000 is a very, very basic actuator, but if all you're looking for is position proportional control or on-off control, this would serve all those needs. The next model is the 2001 series. This one has some enhanced digital electronic features. So it does have programmable electronics. On this actuator here, you can either use a display or there is a port that you can connect up to and program the actuator that way through a RS-485 Modbus communication link. You can either do current or voltage control on this particular model, optional local keypad, and it accepts current, voltage, or digital outputs. So the digital outputs would be coming from your control system to the actuator to control it. And then there are optional programmable relay outputs in addition to the solid state outputs that are on the actuator. So if you had a display that was hooked up to this model, you could configure your outputs for position output, current input. You could configure it for diagnostics that are inside the recorder, like high temperature, for example, or repositions. So there's a lot of different ways you can configure these relay outputs on this particular model to give you some enhanced insight into what the actuator is doing. Last but not least, we have the Herculine 2002. So it has all the features of a 2001, but it also has a non-contact sensor. So we talked a little bit about this, and both actuators has the option for non-contact. And then on the 2003 model, this is the unidirectional model, which only offers up to 100 inch-pounds, 360-degree rotation, and just an on-off input. This particular one, like I said, is not used widely out in the industry, but if you do see some surface combustion integral quench furnaces, most of the time you're going to see this actuator mounted on the damper shaft of the exhaust coming out of the oven. The 2000 series, like I said, you have the options on the far right hand side, no hand wheel, no display, auto manual switch. You can get it with the hand wheel, and you can see on the if I have my cursor over the top of this actuator, this little knob right here on the bottom left, that would be your auto manual switch. And in the hand wheel is the top knob right at the very, very top, along with the display. So you can see the options that we had talked about on the far left-hand side. It is important to let you know that it has a stall for 100 hours without any damage. So this stall that is in the actuator. It's rated for 2 times its rated torque and at 100 hours without any damage. So you can see that these actuators are rated very conservative at 400 inch-pounds, but understand that it can actually see twice that up to 100 hours without any damage. When we talk about the Herculine reliability and robust design, in the middle of this slide here, we got the worm gear. This worm gear is used both on the Herculine 2000 as well as the 10260. And this worm gear here offers a self-locking mechanism by using this arrangement on the spindle. These spindles are connected directly from the motor all the way through to the output shaft of the actuator. So what that does is it minimizes any hysteresis because it's connected right to the output shaft. And then also this is what allows that high torque stall. Since it's self-locking with this worm gear, it can handle up to a lot of stall torque beyond what its rated capacity is, and for very long periods of time. The synchronous motor, AC motor, is what's used to drive both of these actuators. And if you look to the right here, there is a spur gear. This would be on the 10260. On the 10260, there's a little door that I'm going to show you in a little bit on the side that has 6 screws. And if you take that little door off, you will have the main gear, which is hooked up to the motor. You have a spur gear right here that is the fiber mesh gear. And then you'll have a steel gear here that's connected right to the output shaft. This fine mesh gear here in the middle is called the breakaway gear. So as I mentioned earlier on, if you get into 2 times the rated stall torque, this gear will actually break before it damages the AC motor that's on the actuator. So as I said, that this stall gear here is about 15, 20 bucks, and it's very easy to replace as well. Inside the actuator on the 10260, we have this heavy-duty gear that's actually a half-moon shaped gear that rides along this worm gear as it's doing its positioning. So this allows for very high accuracy and repeatability out of the actuator. Last but not least, we have the non-contact position sensor. This is the sensor that's used both in the 2000 series and the Herculine series. And as you can see, it has this half-moon shaped disc on there that will provide a voltage output based on where the actuator is in its rotation. This is the inside workings of a Herculine 2000 actuator, and this is basically showing the thin film pot that's available in the 2000 series, and also the non-contact feedback potentiator. So it looks a little bit different. The thin film pot is encased in a nice plastic cover here so that it's free from getting dust and debris on the slide of the film pot, because if you do that, it becomes very erratic. And then the non-contact sensor, again, non-contacting provides a linear feedback to your control system. Over on top of that thin film pot is the row of mechanical relays or switches that you can adjust by putting a flathead screwdriver into the top of this and rotating it so that the riser on the micro switch can actuate when you want it to during the stroke. This one shows, I think there's 4 switches there, and those are all 4 adjustable with the removing the top lid on the actuator. If we were to remove the top lid on the Herculine 2000 actuator, this is what you would see inside the actuator. Over on the far right-hand side, this is where you would hook up your power, also 4 to 20 milliamp. You have your end of travel limit switches and auxiliary switches below that. You'll have your programmable relays to the left, along with the power supply to the actuator. And then up at terminal block 3 is where you have your communications and some other connections up there as well. But you can see that if you remove the top lid, everything is very easily accessible. And every single lid has on the inside of it a map of the wiring instructions as well. So in summary, on the Herculine 2000 and 10260 actuators that Honeywell provides, again, provides very reliable and accurate positioning of the final control elements that you have hooked up to your PID loop. Rugged construction design, continuous duty operation. Remember that's a big one, especially if you have high ambient temperatures. These actuators do not have braking mechanisms in it, so whereas other lower cost actuators have brakes that can deteriorate as the temperature increases. No non-contact output shaft positioning, enhanced electronics for faster commissioning, startup diagnostics, better efficiency. And again, the Herculine 2000 has models that range from 50 to 400 inch-pounds, and the 10260, which ranges 10 to 300 foot-pounds. With that concludes the PowerPoint presentation. I'm going to stop sharing this. Let's see here. Alrighty. And what you should see now is the 10260 that I have on the far right-hand side here. Jay, can you see the 10260 here that I have pictured on the camera?
Yeah, on the upper left.
Yep, yep.
Yep.
So what you'll see is this front here is the 10260 actuator with the side plate removed. And inside of the side plate, you can see it's very easily accessible. It has the fiber mesh gear that is right between the output drive of the motor, the synchronous motor, and then the large metal gear that's connected to the worm gear that's inside the actuator. This fiber mesh gear here just has a C-clamp collar. So if you needed to replace that, you would remove the C-clamp collar, remove the fiber mesh gear, and then place on the new gear, and literally within minutes you can have the fiber mesh gear replaced. This would be the first place to look at if the actuator was not rotating as you increase or decrease the signal. And then over in the front of this actuator is where you have your crank arm, and then also your synchronous motor here inside the actuator. That provides the rotation of increasing and decreasing. On the far left-hand side of this actuator, as I rotate it, this has your hand wheel, and you got your auto manual switch in order to position the actuator manually or through the hand wheel if you wanted to. With that, I just wanted to show you a couple of those things there. Do we have any questions from anybody online today? Okay, so that concludes our Honeywell Herculine actuator overview for today. If you have any questions or feel for any technical questions or questions on pricing or model selection, please reach out to one of us from Loy Instrument or myself, and I'd be glad to help you. And we will see you next Tuesday. Thanks for attending.